Hello, dear students. I, Abhinav Negi and Dheeraj sir, welcome you all in the beginning of this series, the first session of the series. The name of the series is Old is Gold. Okay, before coming to Dheeraj sir, let me tell you about this series, guys. In this series, we will be taking the handpicked questions of 90s and the very old questions of GATE. The reason being, because we have already taken the series of the complete last 5 years PYQ. In your books, in your assignment, in your practice, you have also done the PYQs many times of last 10 years, 15 years. But what about the PYQs of the early 90s, which are also made by the IITs, and those handpicked questions which are relevant now and can be a potential question in the upcoming years of the GATE exam, that we will be taking in this series. Apart from that, what is more important or very new feature of this series, that in every session of this series, guys, you will be getting a quiz on our BYJU'S exam prep app, and that quiz will be relevant to this subject. Right now, we are doing SOM, so you will be getting a quiz. That quiz is already uploaded in the practice session in BYJU'S exam prep app. Suppose tomorrow the next subject will be environment or TOEM or whatever. So a quiz related to that subject will be uploaded in our BYJU'S exam prep app so that you can have more practice of GATE level question. Okay, and guys, this series you're watching right now on YouTube Plus app. Let me again tell you guys, old handpicked questions of 90s which are relevant now also, that we will be doing in this series. Plus every day, whatever the subject is going in this series, you will be getting the quiz of that subject on the app as well. Before going to the PYQ, question number 1, 2, 10, 20, anything, let me first of all tell or wish Dheeraj sir on behalf of all the students a very, very happy birthday. Today, Dheeraj sir is having birthday. So sir, over to you. First of all, once again, from my side and from various students, happy birthday to you, sir.
Thank you, sir, for making this birthday very special. I'm taking that class with you. That's a matter of happiness. So, guys, thanks for your wishes also in the comment section. So, guys, this series is going to be special because I have seen that many times you do the PYQs, but you never do the PYQs before 2000 generally, because you feel last 10 years, 15 years are enough. But there are some very good questions which are asked in the very previous years of, or you can say before 2000. So those questions we are coming up live here, because generally they are also not available in the books, because generally all the publications are giving last 10 years, 15 years only. So that is why this is going to be very, very important series for you guys. So we are starting with this, and we will also be, as the quizzes already you are getting, also you will get 10-15 extra questions available for practice on our Telegram channels also. Okay, sir, shall we start it now?
Okay, so guys, this is about me. Okay, every day you'll get a quiz, guys. Whatever subject is going on this series in the YouTube, you'll get a quiz on the app. Okay, this is about Dheeraj sir. Telegram of Dheeraj sir is mechanical by Dheeraj sir, and my Telegram is civil by Abhinav sir. This is my class of SOM, complete SOM I am completing on the app. This will be at 4 p.m. Okay, we have done this till now. Tomorrow will at 4 p.m. at is pressure vessels and column. This is every day at 4 p.m. Now this is about the handpick series, and guys, Mega Mock Challenge is there on our app. That is a app free feature where guys you will be getting certain subjects. Okay, in every slot. Okay, let me tell you, like what is the date today? 7 November. So from 28 October to 3 November, these 4 subjects, mechanics, SOM, structure, steel, concrete design is going on. It will be in exactly GATE pattern. These 5 subjects of 65 questions, 100 marks, 180 minutes. Then next subject will be coming. Then next subject will be coming. And this you can give any time from 28 October to 3rd November. Oh, sorry, now the subject is from 11 November, new subject will be coming. Same is in the mechanical as well. Okay, so every group of subjects we are taking for civil and mechanical both. Now, guys, vision courses are available in English and Hindi. Before going further, Dheeraj sir will be, let me tell you again, guys, that Dheeraj sir will be taking initial few questions. Then I will be joining you. Okay, then I'll be taking some questions. Then again, at the end, Dheeraj sir will be again taking the questions. Oh, over to you, sir, the stage.
Okay, sir. Thank you. So, guys, this is for the mechanical. The test is there from 11th November to 18th November. Manufacturing, material science, industrial, and IC engines are the subject. So, guys, now we are moving for the very first question. Okay. So, this is a question from simple stress and strain. And if you see this question, they have given a member like that. Okay. And this is the distance A, this is distance B. They have mentioned below figure shows a rigid bar hinged at A and supported in a horizontal position by two vertical identical steel wire. When they are saying identical steel wire means material is mentioned, Young's modulus is same. Identical means length is same, area is same. Okay. Only the load in them and deformations of there will be different. Rest, length, area, Young's modulus are same. Neglect the weight of the beam, the tension T1 and T2 induced in these wire by a vertical load P applied as shown in the figure. So you need to find out the tensions in the wire. So guys, yes, will you try this or shall I start? This is a question. 4 options are there in front of you. And guys, this is a very good question, and I strongly feel that this type of question can appear in the exam. Yes. Yes, TPM, Papa Ka Ghoda, Nandu, Rohan. So guys, this is a very, very good question. If you want, I will give you hint for that. Okay, Papa Ghoda is saying the answer is A. Very simple. It is not that simple, dear. Okay, no issues. I will be solving it for you. So my dear, if you see this, I am taking it as the longitudinal axis of this member. And my dear, you know that at this point, you are providing a hinge kind of support to this. Actually, this is a hinge support. Okay. So you are providing the hinge support to this at this point. But you know that about hinge, it is free to rotate now. So what will happen because of this load P? This is going to go down like that. It is not going to rotate completely because these wires will not allow that. But when, my dear, this will be going in this position, this wire 2 will be deformed by some amount. That deformation I am showing it by delta 2. And my dear, this wire will be deformed by some deformation of delta 1. Okay, up to this, you will see that rod will take this position. So my dear, now if you see, this is one triangle, you can feel, this is another triangle, you can feel. In both the triangle, this angle is 90, this angle is 90, and this angle is common. If two angles of the triangle are equal, obviously third will be equal, and that is why angle similarity is there. Because of angle similarity, you can write delta 1 by A, delta 2 by B. So I am writing by similar triangle, delta 1 by A is equals to delta 2 by B. Okay, now you are aware that we can write delta 1 is T1 L1 A1 E1. Okay, T1 L1 A1 E1 and is equals to A by B of T2 L2 A2 E2. Okay, and you already know they are identical wires. So E1 A1 L1 L2 A2 E2, they will get cancelled out, and you will get T1 as equals to A by B times of T2. Okay, this you got it. Now, my dear, you got one relation between T1 and T2. Now you know there is a hinge point given. Whenever hinge point is given, you will see in the gate question, you have to take summation moment about hinge to be 0, and then only you will be reaching to the final answer. So you will say summation moment about A is going to be 0. You can see this P is creating anti-clockwise, T1 is creating clockwise, T2 is creating clockwise. So you can write P into L is equals to T1 into A plus T2 into B. So now, my dear, you are already aware the value of T1. Yes, you are already aware about value of T1 in terms of T2. So you would be putting this value, my dear. You would say P into L is equals to T1 into A. And you know the value of T1 is A by B T2. You can also write from here T2 is B by A T1. Okay, I am putting this B by A T1 plus B by A T1 into, this is nothing but B. Yes, now my dear, you can see from here T1 is there, T1 is there. So you would be getting here P into L is equals to T1A square plus T1B square, and divided by A will go here. So T1 is coming out to be P into A into L divided by A square plus B square. Similarly, you will be getting T2 as P into B into L divided by A square plus B square. So you can see the answer for this question is T1 is PAL. Okay, T1 is PAL, TB is PBL. B is the right answer. Very good. Yes, thanks, Ami. D2E, yes, Rohan, very good. TPM, very good. Yes, Harkesh Shekhar, thanks for your wishes. So guys, the first question answer is B. Moving to the second question, this is from torsion. This is from torsion, my dear. So guys, do like and share the session. Do like and share the session. They are not those PYQ which generally you have done. They are new PYQs for you. And we have taken only good questions which are relevant for these years, which can come straight away. If you will see, it is happening in many subjects. In industrial also, I have seen 3 questions repeated. In strength of material also, 1 to 2 questions have been already repeated. Okay, like if you see 2015 paper, 1995 question was as it is asked. So that is why these questions are very relevant. So this question is saying 2 shafts A and B are made up of the same material. When the material is same, I can say G1 is equal to G2. Then my dear, the diameter of shaft B is twice that of A. So they are saying diameter of B is 2 times of diameter of A. Then my dear, they are saying the ratio of power which can be transmitted by shaft A to that of B. So power transmission capacity of A to B. If you remember, when we are doing these derivations, we are telling you that this ratio is very much equals to TA by TB. And that ratio is also equals to ZP of A to the ZP of B. Okay. So you know that when that is the case, you would be writing it as dA ka cube. Why dA ka cube? Because you know what is ZP. ZP is pi by 16 d cube. So when you will be putting this pi by 16 dA ka cube divided by pi by 16 dB ka cube, you already are aware that dB is 2 times dA. So answer will be coming out to be 1 by 8. Yes, Rohan, you are correct. Papa ka Ghoda, TPM, everybody have given the right answer. The answer for this is going to be C, that is 1 by 8. Very good, guys. Moving to the question number 3. And this is related to principal stresses and strain. First of all, I am taking 5 questions. After that, Abhinav sir will be joining for his questions. Then once again, I will come back. Okay. So if the 2 principal strains at a point are 1000 into 10 power minus 6 and minus 600 into 10 power minus 6, then the maximum shear strain. This is easy question. And next question is something very beautiful. And that question will give you a feel of gate actually. Okay. So be ready for the next question and answer this easy question before. What would be the answer for this? Okay, Nandu, Murli. So you guys are saying answer is C. What about others? Rohan, TPM. Okay, Rohan is saying the answer to be A. Okay. Okay, what about others? Alekia is saying A. Papa ka Ghoda is saying A. TPM is saying C. Okay, so I would like to say, my dear, whenever you are writing the maximum shear strain, when you write the formula for maximum shear stress, tau max is coming out to be sigma 1 minus sigma 2 by 2. But my dear, whenever we write the strain tensor with the help of stress tensor, then sigma is replaced by epsilon, tau is replaced by gamma by 2. So that is why you would be having the gamma maximum by 2 is equals to epsilon 1 minus epsilon 2 by 2. So my dear, 2 by 2 will get cancelled out. And now you can very easily say what would be the answer. Gamma max is going to be epsilon 1 minus epsilon 2. Epsilon 1 is 1000 into 10 ki power minus 6 minus of minus 600 into 10 ki power minus 6. Answer will be 1600 into 10 ki power minus 6. And answer will be C for this. This is a beautiful but easy question. Now, my dear, the next question is slightly new. New maybe for those who have not done this chapter in a nice way. But otherwise, this is a beautiful question. This is a wonderful combination of principal stresses and thin pressure vessels. If you see the question, a thin cylinder of 100 mm internal diameter and 5 mm thickness is subjected to an internal pressure of 10 MPa and a torque of 200 Newton meter. Calculate the magnitude of the principal stresses. I will give you hint for this because this may be a new type of question, because in the recent year, GATE have never asked this question. So my dear, you already know whenever we are talking about a thin cylinder state of stress. So you are aware that when we make the thin cylinder, when we make the thin cylinder like this, when we make the thin cylinder like this, when we make the thin cylinder like this. So you know that because of the pressure, there is a circumferential stress coming, and because of the pressure, there is a longitudinal stress coming. So you would be making it, this is going to be the circumferential stress, which is PR by T. Yes, that you are aware of. Okay. And my dear, this would be sigma longitudinal. This will be PR by, sorry, PD by, this is PD by 2T and this is PD by 4T. Or if you want to write in the form of radius, it is PR by T and it is PR by 2T. Choice is yours in which term you want to write it. So generally, my dear, we call these stresses as the principal stresses because there is no reason for shear here. But my dear, if you clearly see this question, they have mentioned that a twisting moment is applied on the cylinder. So when you would be applying a twisting moment onto this cylinder that is equals to T, obviously it will be creating some shear stresses. And my dear, the shear stresses, if it is going to create on these planes, we will be having the shear. And whenever normal and shear are present together, it is said to be combined loading. And in this case, you cannot say this circumferential and longitudinal to be principal stresses. You need to find out now the principal stresses with the formula. Now, by looking at this, you can say circumferential stress is your sigma xx, longitudinal stress is your sigma yy, and you know that there is a stress tau. So my dear, tau is your tau xy. So my dear, now if you know the formula, of principal stresses sigma 1, 2, you would be aware that sigma xx plus sigma yy by 2 plus minus square root of sigma xx minus sigma yy by 2 ka square into plus tau xy ka square. So my dear, this is the formula for principal stresses. But to find out the principal stresses, you are having sigma xx, you are having sigma yy, but you don't have tau xy. So my dear, you will apply the torsion equation. You know T by J is equals to tau max by R is equals to G theta by L. So my dear, whenever you are talking about the tau max or our tau xy, that will be coming out to be TR by J. Now, my dear, when we are talking about J, here is the real twist. Here, this is a thin cylinder. If it would be a hollow shaft, we know that pi by 32 d naught ki power 4 minus di ki power 4 will be the value of J. But here, my dear, whenever we are going to have the thin section, then the value of J is given as 2 pi r cube into T. This is the value of J for the thin section. You derive this in the engineering mechanics, and this is the approximate value for the thin section. In some of the books, they are writing this as pi dt into d square by 4. So the choice is yours. Both are having the same meaning. You can use any of the formula and you can apply the J. You will get tau xy. Once you will get tau xy, you need to put here and you will be getting the principal stresses. This is a wonderful question. You won't believe this type of question have came in GATE exam many times for 5 marks also, because before 2003 they were coming for 5 marks also, and the same question have been repeated 2 times for 2 marks also. So that is why I have taken this. You can have this type of question because 1 to 2 questions GATE peoples are asking with that much length. Don't worry, I will help you for calculation. You tell me what you are getting the circumferential stresses. What you are getting at circumferential stresses. Circumferential stress is sigma xx, sigma c. It is P d by 2t. What you are getting the value of this? Can you tell me? I will help you in the calculation. Don't worry. Because majorly I wanted to teach you this concept. Yes, Murali, Papa Ka Ghoda, Rohan, TPM. Tell me the value of sigma circumferential. Tell me the value of sigma circumferential. You can see they have given the value of 100 mm internal diameter. They have given the thickness 5 mm. They have given the pressure 10 MPa. They have given the torque. So when you will be putting the value of PD by 2T, you would be getting the circumferential stresses would be coming out to be 100 MPa. Okay, 100 MPa. When you will be talking about sigma yy, that is going to be longitudinal stress. That is PD by 4T. And that will be coming out to be 50 MPa by default. Yes or no? And when we will find out the tau max, that also I have calculated for you. Tau max will be coming out to be tau max, which is our tau xy, that is coming out to be 24.2 MPa. So when you will be putting these three value here, you will be getting the principal stresses. Wonderful, wonderful, guys. So now you need to find out sigma 1 and sigma 2. I have given you all the three values after calculation. Solve it and get the answer. Very good, Papa ka ghoda. Wonderful, dear. So now tell me the value of sigma 1 and sigma 2. Tell me. This is a wonderful question. TPM, there are, okay, you have given already option B, 109 and 40.2. That is correct. So whatever the answer TPM is giving, it is correct answer. 109.8 and 40.2. 109.8 and 40.2. So I feel everybody got it. This is a beautiful mixture of torsion, thin cylinder and principal stresses. Wonderful, guys. So now this was a heavy question, lengthy question, slightly difficult. So let us move to some easy one. This is question number 5 from my side. For the case of a cylinder column of length L and flexural rigidity EI built in at its base, built in mean fixed support. Okay, like this. So they are saying free at the other end. What is the Euler critical load for this? What is the Euler critical load for this? What is the Euler critical load for this? Tell me. So Rohan is saying the answer is A. This is one end fixed, other end free. One end fixed, other end free. You know the general formula is n square pi square EI upon LE ka square. For this case, what is LE? Okay, Sushant is saying A. Arfat Qazi is saying A. Okay. So my dear, you know that for this case, LE is 2L. LE is 2L na? For this case, one end fixed. They are saying one end fixed and other end free. So when you will be putting 2L, PE will be coming out to be take N as 1. Pi square EI by 4L square. D would be the right answer. Formula भूल गए क्या सभी लोग? Yes. So now I will invite Abhinav sir to join us for his question. And after Abhinav sir, I will once again join you for the pending questions of mine. Okay, sir, over to you.
Okay. Thank you, sir. So guys, here on, I am taking few more questions. And then again, at the end, Tejas sir will be coming. Okay. So let's move, guys. Okay. This is the question, guys. What is written here? The deflection of a spring with 20 active tons under a load of 1000 Newton is 10 mm. The spring is made into two pieces, okay, and equal pieces because 20 tons are turned into 10 active tons. And they are placed in parallel. Then same load is applied. Now what will be the deflection? Earlier what is happening? That you are applying 1000 Newton. So deflection is 10 mm. Now this spring is cut into two parts, exactly two parts. And two parts are put in the parallel. So now with the same load of 1000 Newton, earlier deflection was 10 mm. Now what will be the deflection? Before solving this, let me tell you, the strain energy is this of a spring, 32 p square r cube into n by gd4. Applying Castigliano's theorem, deflection is given by del u by del p. So from here, deflection is given by 64 p r cube into n by gd4. What is p here? Load. What is r? From the center line, the radius at the end, that is r, n is the number of tons, and d is the thickness of these wires. D is the thickness of these wires. Now, G is the shear modulus. This is the delta. What is stiffness? Stiffness is P by delta. So P by delta from here is GD4 upon 64 R cube into N. So when we cut the spring into two parts, material will be same. This D will be same. R will be same. N is halved. So cutting in the two parts, earlier the stiffness is K. If earlier the stiffness is K, now it will become 2K. Okay. So the K equivalent now in this case for parallel is 4K. Okay. And same load 1000 Newton. So deflection is P by K. So K is 4 times. K is 4 times. So deflection will be reduced by 4 times, because earlier it is P by K and now it is P by 4K. So it is 2.5 mm. It is 2.5 mm. That is D option. Give me yes or no, guys. Okay. Give me yes or no, guys. Come on. I'm again telling those who have just joined this session. This is the first session of this series. The series name is Old is Gold. Here we are dealing the questions of 1990s, which are relevant now also. Okay, and this session is running simultaneously on YouTube, and same Abhinav Negi, same doing hand like this, same doing hand like this will be in app also. Every day in this series, whatever the subject is going on, that same subject you will be getting on the same quiz on the subject. Okay, quiz of the same subject you will be getting every day on app. Okay, now let me move to this question. This has been asked in the PYQ. Come on, hit it. Hit it, guys. The stress is 95. What is the maximum stress? Of course, the maximum stress will be when the area is minimum. Okay, here at the center, just exactly at the center. Here, just exactly at the center, the stress will be maximum. Okay, now what is the force, guys? Stress into area. Force is 95 and area is 10 and inside thickness is suppose T. Inside thickness is suppose T. Inside thickness is T. So it is 95 into 10 into T. Now force there, sigma max is equal to force by area. Force is 95 into 10 into T upon area. So 10 centimeter, 5 centimeter is the whole. So area left is 5 into T. So it becomes 190 megapascal. Guys, can any one of you tell me on the comment section? Can any one of you tell me on the comment section? Sir, इसका वेटेज कितना है पेपर में? इसका वेटेज कितना है पेपर में? किसका बेटा? किसका? Okay. Now, इसका साइबर क्राइम कर देना. ठीक है, अभी कंप्लेंट कर दो. जो भी इसका आईपी एड्रेस रहेगा वहां पहुंच जाएगा बंदा. ठीक है, अभी कर दो. जो भी रहेगा बंदा, आईपी एड्रेस जिस भी एड्रेस से खरीदा होगा, परचेस किया होगा, वहां पे बंदा पहुंच जाएगा रात तक साइबर क्राइम से. ठीक है, स्क्रीनशॉट भी ले लो. Okay, now guys, can any one of you tell me that this sigma max is on which assumption? You might be thinking sigma max is fine. It is in no assumption. Can you tell me sigma max is on which assumption? Tell me. This is on the assumption that there is no stress concentration. That there is no stress concentration, guys. In actual life, in actual reality, stress is where there is discontinuity. Here there is discontinuity, na? Because here it is material and here is empty. Okay, at this point, here it is material, here it is discontinuity. So actually at these points, stress concentration will be there. There will be more stress. Guys, this green points, na, and this orange point. This green point and this orange point. Orange point will, in reality, orange point will be having lesser stress. Because in orange point, material can go everywhere. In orange point, material can go everywhere. But in green point, in one of the side, the stress is, there is empty, no material, only material is here. So green point stress is more. In actual life, if you see the stress now, stress will be like this, and then where there is hole, stress will be more. Okay, stress will be more. So this is the actual, but in our assumption, we assume constant stress all over. So that is 190. Give me yes or no. Yes, of course, we are doing only those questions which are relevant now also. Now, let us move to the next question, guys. An elastic body is subjected to a tensile stress X in a particular direction and a compressive stress Y in its perpendicular direction. Okay, so here is a tensile stress X and here is a compressive stress Y. Okay, and X and Y, of course, it is one is tensile, one is compression. Magnitude wise, they are not same. Okay. Now, on the plane of maximum shear stress, what is this condition? Suppose if their magnitude wise is same. if magnitude wise they are same, then what happens? What happens? Then in that case, our Mohr circle will be like this, and this will be the X point of tension, and Y is compression like this. Then on the plane of tau max, because it is exact center is exactly at the origin, on the plane of tau max, on the plane of maximum shear stress, the normal stress will be 0. A will be the option. A will be the option in that case. But here X and Y are not same. This is the case when the magnitude of X is equal to the magnitude of Y. But in our case, the Mohr circle will be looking like this. This is the normal stress. This is the shear stress. This is the normal stress. And this is the shear stress. And our Mohr circle, suppose X is greater than Y, then it will be like this. If Y is greater than X, it will be somewhere here, but not symmetrical. So on the plane of tau max, this is the tau max. In the plane of tau max, this is the plane of tau max. Here we are getting X coordinate also. We are getting Y coordinate also. Okay. So both normal shear and shear stress will be coming. Give me yes or no in the comment section, guys. Give me yes or no in the comment section. Everyone, come on. Have you gotten? Are you getting this or not? Are you getting this or not? Please tell me. Please tell me. Come on. Everyone. Okay. Moving further to the next question. A cylindrical elastic body is subjected to pure torsion about its axis. Pure torsion means that no movement, no shear stress, no axial force, nothing is coming. Pure torsion. Suppose this is a cylindrical body like this. Okay. And suppose it is fixed here also. And in this fixed body, we are applying a pure tension like this. Sorry, pure torsion like this. Now, if I consider this plane, now understand this one. In this only shear is coming. So if I take a plane like this, so it will be a case of pure shear because torsion only produces shear. Okay, and my sign convention is put a right hand thumb rule. If it is going inside, it is a positive torque. Positive torque causes positive shear stress. This element, as per my sign convention, is positive. Now, this is the case of pure shear stress. So, pure shear stress represent. So, this is the shear stress. This is the shear stress. This is the sigma. Let me take a different color for this pure shear will be like this. Okay. Now, actually, this blue one, representing this point on the Mohr circle. This blue one is representing this point on the Mohr circle because these points are having tau, but these points, the x-axis is 0. The axis is 0. So this thing is representing these points. Now, this is the shear stress when we take a element which is directly on this plane. Now, when we rotate, where is the principal stress coming? Where is the principal stress coming? So, principal stress, major or minor, are coming 90 degree from here. So, in Mohr circle, it is 90 degree. In Mohr circle, it is 90 degree. So, in real life, the angle is represented by half. So, it is 45 degree. Okay. So, maximum tensile stress or also the compressive stress is at 45 degrees. So, in this direction, if I cut a plane, this plane, which is at 45 degree, will be having the maximum principal stress. Guys, one question also comes in this, on objective also, subjective also. They give a strain gauge at a 45 degree angle. Okay, they give like this. They give a strain gauge at 45 degree angle. Okay, this is 45 degree from the axis. Now, whenever we do such questions in objective and subjective, we are thinking, yeah, only one strain value is given, something is missing in the question. No, something is not missing. Actually, that strain value, that strain gauge which is at 45 degree, that strain gauge will be giving the principal strain. That strain gauge will be giving the principal strain. Give me yes or no. Have you understood or not? Have you understood or not? Everybody on the comment section. Everybody on the comment section. Please, 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 come on. Come on, come on. How tension, why not shear? How tension, why not shear means? I'm not getting. Which question, Yamuna, you are asking? 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 Which question, Yamuna, you are asking How tension? Why not shear? Because at 45 degree when we go, so 90 degree, this is only x coordinate. Okay, shear y coordinate is 0. So at 45 degree angle, when we 45 degree in real life, that means Mohr circle we go 90 degree. So y coordinate, that is shear, is 0. Now this one, please. Everyone, Mohr circle for strain. Guys, let me tell you that in last 3 years in civil engineering, every time, in every set, morning set, evening set of 2021, 2022, morning set, evening set, 2023, morning set, evening set of civil, they are asking a question of transformational stress. Last 3 years, in morning set, evening set, both times they are asking a question of transformational stress. So if I represent for strain, they may ask this here. So here it is gamma by 2. Everywhere in transformational stress, we are using, in transformational stress, wherever we are using sigma, we are replacing by epsilon, and where we are using tau, we are replacing by gamma by 2. Let the Mohr circle for strain, the two principal strains are this and one is minus. Okay. So one is 1000. This is 1000 into 10 ki power minus 6. And this is how much? Minus 600 into 10 ki power minus 6. So what is the diameter of this? Diameter of this is 1600 into 10 ki power minus 6. So what is radius? Radius is 800 into 10 ki power minus 6. And what radius is representing here? There the radius in case of stress. In case of stress, radius is tau max. So here the radius is, this value is giving the gamma by 2 max. So radius is, that is 800 into 10 ki power minus 6. The radius is this, that is representing the maximum y-axis. That is gamma by 2 max. So gamma max is equal to 16 into 10 ki power, 1600 into 10 ki power minus 6. That is C option. Understood? Understood? Yes or no? Yes or no? Everyone? Got it? Mahesh? Deepa, good. Everyone got it? Shall we move further? Shall we move further? Okay. Now this is the question. Interesting question. This is a 3-star question, yaar. This is a 3-star question. Now they're asking that determine the temperature rise necessary to induce the buckling in a 1 meter long circular rod of dia 40 mm, shown in the figure below. Assume the rod to be pinned at its end and coefficient of thermal expansion is alpha. With usually in Euler's buckling load, what you do in Euler's buckling load, due to force, there is a buckling load. Like for this case, the critical load is pi square E into I minimum upon L effective square. So L effective for both side pin is L square. So pi square E, I minimum is pi by 64 into d ki power 4 and L square. So everything is given here. Now this is the load. And due to the stress, guys, due to the thermal stress, both sides it cannot elongate, na? Okay, both sides it cannot elongate, na? So both sides it cannot elongate. So what is the stress in that case? E alpha T. E alpha T, tell me please. The stress is E alpha T, yes or no? Yes or no on the comment section. Yes, stress is E alpha T. So stress is E alpha T, but we want PCR, na? PCR is not stress, it's load. So E alpha T into area. So what is area? What is area? Pi d square by 4. Now here in this whole equation, only E to E will be cancelled. Okay, pi diameter is known, everything is known. T we have to find out. Assume the rod to be pinned, the coefficient of thermal expansion is this. Assume uniform heating. But we have to determine the temperature rise. So everything is given. We just have to find out the temperature. Tell me how much you are getting it. How much you are getting it. Everyone, not having calculators. Not having calculators. Okay. So here, guys, what we are having, kahan gaya? the temperature value, I have already calculated for you, so the time is not wasted in the class. Okay, the area temperature is 49.34 degrees Celsius. Temperature is 49.34 degrees Celsius. Guys, let me again tell you that I'm coming live for SOM free crash course. SOM free crash course on app. SOM free crash course on app daily at 4 p.m. Okay, so tomorrow also on app, I'll be there. Now this one, what is the stress here? They have not given. Sigma y not known. Of course, this tau xy value, is 3 because in adjacent faces shear stress is equal. So sigma x is equal to 8. Sigma y is not known. Tau xy is equal to 3. And sigma x dash at 45-degree angle is 2 value. Now, what they are asking the principal stress. Can any one of you? Yes, TPM. Good. Can any one of you tell me the method for solving this? Can any one of you can tell me the method of solving this? Okay. This tau xy is this one, na? This tau xy is this one, na? So it will be minus. Now we know that sigma x dash is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Now sigma x dash is 2. Sigma x is how much? 8 plus sigma y by 2 plus 8 minus sigma y by 2 into cos 2 theta, cos 90. So cos 90 means 0. Plus tau xy is minus 3 sine 2 into 45 sine 90. Guys, from here, 8 minus 3, 2 minus 3, so it will be 5 here. 5 into 2, 10. Sigma y is equal to 2. Sigma y from here is 2. Now, when sigma y is known, Rohan minus 10 क्यों भाई? Rohan minus 10 क्यों भाई? अभी बताया तो. Minus 10 will be the answer. Why? Why minus 10? Why minus 10? This is tau xy, na? This is tau xz. They are asking in xy plane. If you, for this question, Rahul, you are saying? For this question? Are you saying for this question? Now, guys, sigma 1 is sigma x, or sigma 1 slash sigma 2 is sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy square. Now sigma x is known, sigma y is known, tau xy known, everything is known. From here, the final value is 9.2 megapascal, the major principal stress, and minor principal stress is 0.7 megapascal. Minor principal stress is 0.7 megapascal. Give me yes or no. Okay, no, Rohan, here we are getting this one. Here we are getting this one. Give me yes or no, please. Give me yes or no. Tell me. Everyone. Any doubt till now? Any doubt till now, please? Please, guys. Vineet, how are you? How's the health now? Okay. Now, guys, okay. Okay, this is the scholarship test on 11th and 12th November. You can give this test free of cost in our app, and you can get up to 90% discounts. And this is the workshop roadmap to secure All India rank under 100 in GATE 2025. This will be on 8th November at 7:30 p.m. by Joshit sir. Okay. So let me move further. Yes. Sir, अभी 2 क्वेश्चन बचे हैं.
Okay, sir.
Birthday boy.
अरे सर मुझे लगा शायद हो गए.
Okay. Okay, it's okay, Vineet. Now, which of the following diagrams show correctly the distribution of transverse shear stress? Guys, whether it is rectangular, whether it is triangular, whether it is circular, whether it is T, whether it is I section, any section, just remember one thing. Just remember one thing. The shear stress will always be zero at top and bottom. Shear stress will always be zero at top and bottom, and parabolic variation. Zero at top and bottom, parabolic. Zero at top and bottom, parabolic. Zero at top and bottom, parabolic variation. When area suddenly reduce, so stress will suddenly increase like this. From this you can draw for anyone. So this will be the B option. The curvature is never like this. This is never linear, never constant. Never the curvature is like this. Always the curvature is like this. That concave inside, convex outside. Now, this one, have the stiffness K1 and K2. Okay, which of the following arrangement offers a stiffness of this? Okay. So what is the stiffness of A? Stiffness of A, 1 by K equivalent is 1 by K1 plus 1 by K2 plus 1 by K3. So K equivalent here is K1, K2, K3 upon K1, K2 plus K2, K3 plus K3, K1. Okay, sir. Got it, sir. Now for sir B option. Okay, so that is K1 plus K2. K1 plus K2 in parallel. So it will be series like this. Then K2. So here 1 by K equivalent is 1 by K2 plus 1 by K1 plus K2. So here the LCM will be K2, K1 plus K2. So here it will be K1 plus K2 plus K2. Okay, 1 by K equivalent. So from here, K equivalent is K2, K1 plus K2 and K1 plus 2K2. K1 plus 2K2. यही है क्या? यही है क्या? ये भी नहीं है. तो इसको फिर अब अपन इरेज करते हैं. सी पे जाते हैं. सी पर जाते हैं. सी ऑप्शन. ओके. किसी का आया क्या अभी तक कोई आंसर? Anyone is getting any answer till now? Tell me. Okay. सी पर जाएंगे इसके आगे. तो सी पे तो कुछ हो. K1 plus K2, K1 plus 2K2 होगा इसका. तो सी तो हो ही नहीं सकता. तो डी आंसर लग रहा है. तो वो आ जाएगा 2K2. Those two are in parallel and one is K1. Okay. So 1 by K equivalent is 1 by K1 plus 1 by 2K2. So here it is 2K1, K2, 2K2, 2K2 plus K1. This is 1 by K equivalent. K equivalent is reciprocal of this. That is matching. Okay. So D will be the answer. D will be the answer. Got it? Got it, friends? Everyone? Everyone got it now? Okay. Now this question, calculate the stress at the bottom of support of point A. Here we want to find out. So guys, here the stress is two stress. One is direct stress and one is bending stress. Now direct stress is compression, force by area. Area is pi d square by 4. So it is 4F by pi d square. This is the direct stress. Now, what is the bending stress? First of all, bending stress, direct stress is compressive. Okay. Now, what will be the bending stress, guys? M by I into Y. M by I into Y. And that M by I into Y will be compressive or tensile. Please let me know. I want to see all your answers. I want to see all your answers. That M by I into Y will be tension or compression. Will be tension and compression. This is compression. Tell me, please. Tell me, please. Everyone. That will be tension or compression. That will be tension or compression. The movement about this will be like this, anti-clockwise. Okay. Or here I can say both are same, na? So this F will be trying to make it like this. So it will be tension. I'm again telling you. I'm again tell you. Guys, the movement is what? About A, the movement is anti-clockwise, like this. So this kind of, suppose this is a beam and movement is this, anti-clockwise. So anti-clockwise movement will make it like this, na? So tension at the bottom, na? So here it is, the sigma bending is M by I into Y. So what is the movement about this axis? F into D by 4, D by F into D by 2. This is the movement. What is I? Pi D4 by 64. And what is the Y? Distance from neutral axis. The distance from neutral axis D by 2. If you solve this, okay, if you solve this, you are getting, let me tell you, you are getting a 16F by pi D square. 16F by pi D square in tension. And this is in compression. So net is 12F by pi D square. Okay. So 16 in tension and 4 in compression. So net answer will be 12F by pi D square. Okay. And since the tension stress value is more than compression, so this value will be in tension. Okay. Clockwise कैसे? आपके पास ये फोर्स है ना ऐसा, तो न्यूट्रल एक्सिस के अबाउट कैसा मूवमेंट लगाएगा? एंटी क्लॉकवाइज. गॉट इट खान साहब? गुड विनीत. 12, हाँ 12, good. Yes Dheeraj sir, now you can come. Okay, so guys, I'll meeting you again at 4 p.m. on the app free class. Okay, thank you Dheeraj sir, thank you.
Okay sir.
Happy birthday once again.
Hi sir. So guys, now we are left with some of the questions. Let us complete that. 2-3 questions are left. Okay. So this question is, just wait. Yes, this is the question from Torsion. So here they are asking, the compound shaft shown is built in at two ends. It is subjected to a twisting moment T at the middle. What is the ratio of the reaction torque T1 and T2 at the ends? So guys, let us see how many of you give the right answer for this. You know, for that we have two things. The one equation is T1 plus T2 will be equals to T. Okay. And the second equation will be theta1 plus theta2 is equals to 0. You need to apply these two equations and you will be getting the value, the ratio of T1 and T2. Try this question, guys. This is from Torsion. I hope everybody would be giving the right answer for this. Yes, Prakash, Vineet. So Vineet is saying the answer to be A. Okay, what about others? So Vineet, you are here after so many days, I feel so. Yes, what about others? What would be the ratio, guys? What would be the ratio? So my dear, you know that when you will be using this equation, this theta1 will be coming out to be minus theta2. And you know it can be written as T1 L1 by G1 J1 is equals to minus of T2 L2 by G2 J2. And they have mentioned that the compound shaft, it means they are taking the same material, and length, when we talk about, they have given the same length. Length will get cancelled out. So only the difference is in the diameter. So we can write now T1 by T2 as equals to minus of J2 by J1. Forget about minus sign, we need the ratio. So when we are talking about J2 by J1, it will be pi by 32 D2 ka 4 by pi by 32 D1 ka 4. I feel you will be getting the answer as, are you getting 1 by 16? Are you getting 1 by 16? I feel it is J1 by J2. Yes, D1 by D2. So the answer will be 1 by 16. So A is the right answer. A is the right answer. Yes, very good. So A is the right answer. Moving to the next question, guys. Moving to this question already have been done by sir. This also have been done. Now, before this, let us do one more question. This is from SFD BMD. This is from support SFD BMD. a concentrated load Px on a simply supported beam. So we are having a simply supported beam like this. We are having a simply supported beam like this. And on this beam, we are having a load P acting in such a way that it is at a distance L by 3 from left-hand side support. This is P, L by 3, 2L by 3. This is point A, point B. Now they are asking you to find out the bending moment at the point of application of load. So already you know that what kind of bending moment diagram you would be getting. Even without making that, you can get the answer. Okay. So you just need to solve it, or I am deleting it, is not required actually. You can directly find out by finding out the support reaction. Solve it. You know this will be RA, this will be RB. So find out the support reaction by shortcut. After that, you can directly get the moment. Okay, already answer have been given by you guys. Yes, we need to apply shortcut only. You will be having RA as equals to, RA will be equals to what? RA will be 2P by 3 and RB will be P by 3. So you know what would be the moment? Moment at C will be, this is 2P by 3 into, yes, L by 3, answer will be 2P by 9. So D is the right answer. D is the right answer. Yes, very good, guys. So we are now moving to the last question. Yes, this is the last question. So guys, this is the case you have seen at the time of bending when we study beam of uniform strength. A tapered cantilever beam of constant thickness is loaded as shown in the figure. The bending stress will be, so maximum near the fixed end, maximum at x is equals to 1 by 2L, maximum at x is equals to 2 by 3L, uniform throughout the beam. So you can see width is varying like that. Width is varying linearly. So width is varying linearly. So if we are going to take two sections, one at a distance of x, other at a distance of L. So my dear, if you are going to write the bending stress at a distance of x, you will be having minus P into x is the bending moment, and BD square by 6. BD square by 6. You know B is variable. So BXX. Then bending stress at length L will be written as minus P into L divided by the total width is B, let us say at this end. So this is B into D square by 6. And my dear, if you will see that, you can see that key width is varying linearly. So width is varying linearly. If we go by the reverse method, because we have seen this derivation, if I take this bending stress as equal, then what you will be getting, minus PL by BD square into 6 is equals to questions which are conventional for your homework. Okay, what is that question? This question is saying, make the SFD BMD. They have given this compound beam to you and you need to make the SFD BMD for this case. So this is a conventional question. I intentionally kept it. This came for 5 marks. This you can draw it and you can share it on my Telegram channel if you want a check over it. Mechanical by Dheeraj Sardana is my Telegram channel. So this is the homework question for you guys. Okay. Is it clear for everyone? Video is coming or not, guys? I feel there is no such problem, Yamuna. Yes. Everybody, is it clear? So guys, this is the completion of this session. You can also attempt the quiz now. Quiz is available at BYJU'S exam prep app on this subject only. Every day, whatever you will be having the session, for the same session, a quiz will be uploaded on the app so that you can practice by yourself also. Okay. So after this question, this session is over and now you can attempt the quiz. And there also, if you find any difficulty, you can ask it on the Telegram channel. We are always there to help you. Okay, guys. So with this, we are saying goodbye to you and we will be meeting again for the next upcoming topics. I would like to say, if anybody of you is preparing for BHEL, then my dear, for civil tomorrow, for mechanical day after tomorrow, we are having in the morning a mock test for BARC, sorry, not BHEL, BARC. So for BARC, we are having a mock test. We will be meeting for that day after tomorrow for mechanical at 10:30 a.m. and tomorrow is for civil at 11 a.m. So anybody who have applied for the BARC is going to give the exam for technical officer, you can join the mock test. So goodbye guys for this particular session. Okay, goodbye.